Hello guys, this session will be covering some basic information about natural language processing and chatbots. And this is the topic which has been voted somewhat high in our group, and most of the people wants to know about this thing. I think most of the people are working on chatbots thing. So let me see what is natural language processing and chatbots. Before getting into the session, I just want to introduce myself. Myself Murugesh, and I just completed my BE degree in computer science from Jansen's College, Coimbatore, and I'm working as a junior research engineer in airbots technologies. And I had been done my internship with speech recognition and Tamil words under RAAIF as an intern. And I am also contributing for the projects that has been done in RAAIF. I previously worked with NLP speech recognition and reasoning system as an open source contributor, and this is my GitHub repository link. I have several repository, and the main thing is there's a repository called Art Intel, in which there are many tutorials regarding NLP, CV, reasoning systems, fuzzy logics, etc. Let's get into the course, and this is what we plan to cover in this session. And natural language processing and its application, this is the first topic. And natural language understanding, actually there's a difference between natural language processing and understanding, and we'll be seeing the difference and some intro about natural language understanding. We can't able to cover much detail in natural language understanding because it's somewhat tedious than natural language processing. And then introduction to chatbots, and as you know, this PPT will be making yourself bored and crispy. So I plan to include some practical sessions like developing a simple chatbot using AML, and we will also get into we'll be seeing some principles and formulas in natural language processing. We will try to implement it in Python using some toolkit. And then there are some people in our group who want to know about machine learning and what actually machine learning makes our society, and some other things related to machine learning. That's what we call it, machine learning revolution. This is machine learning is one of the main thing in industrial era. So let's talk about something like that. And next, future of AI, does it steal your job? I think you should wait for that thing till the last slide because it's somewhat more interesting, I hope so. Then getting into natural language processing. Before proceeding, what is natural language processing? I need to make sure that you guys really using this natural language processing in your day-to-day life, and you should be knowing this works by this principle. Okay, let's take example Google. What countries border the Black Sea actually? If you see before 5 to 6 years before in the Google, it is some newborn baby, you won't be getting this much clear answer. The Black Sea is an island located between. This questions has been related to been parsed with multiple websites and multiple content, and it just retrieve what is the exact information that should be reproduced as an answer for this question. Okay, I mean this is an AI, but this is an expert system producing a better answer for a better question. And IBM Watson, there are many challenges for IBM Watson and many other AI, which actually gets language as an input and produce the same language as an output. The language processing is done by natural language processing, and there are the principle what you're going to see is something like a baby step, and this is actually we can able to proceed with multiple tedious principles and process in natural language processing. But for those things, the initial and conceptual formulas are being stated in these sessions. And then speech recognition, this is one of my project. It actually not only seeks attention in natural language processing, coding or something, but it also diverge in the field of signal processing, sound engineering, etc. But considering natural language processing, speech recognition systems has came to a boom like hello Google, Siri, etc. This thing exactly monitors our speech. When it gets what we say, it need to process the thing. Okay, right? This process is being made by some NLP techniques. Okay. Then like machine translation. This is not yet completely developed phase of machine translation. There are some bugs and there are some more improvement have to be done in Google and any other machine translation system, and the people have been working on those things. This Google machine learning system has been regarded as one of the top machine translation system. Even though it produced some bad result, it produced some decent result. That's okay. That's like this is what we plan to see in this natural language processing particular area. These concepts, right? These 7 concepts are not just like there are many concepts in natural language processing, but these are like principal and vital conceptual thing. Like when you go for natural language processing in some workshop or some other thing, you'll be getting to know like sentiment analysis, text retrieval, information retrieval, text processing, text predictions, etc. But actually, those things they'll be talking to you about the Python course thing like that, but they won't be taking you to the basics of NLP. So the basics of NLP is something you haven't heard before. This is the basics of artificial intelligence. By this laws and formulas only, all other programs and libraries are being working on. And if you know this basic thing and some other basic thing, you'll get to know what the exact NLP does and what sentiment analysis mean. Sentiment analysis doesn't mean like predicting a sentiment actually. Sentimental analysis is something like predicting whether it is like whether it's like a false positive statement or true negative statement, or like something like if you say like I don't like this film, it doesn't mean that you are in this mode, you're in that mode. The system just predicts like you don't like this film, it's a false statement actually, right? That means you're imposing some false aspect about the film. Okay. Currently some deep learning techniques are being applied to sentiment analysis with images and text, but those things involves much more computation, much more concept than NLP. Current NLP deals with a particular domain of AI. Okay, we'll see what are those things. Like first, part of speech. Part of speech is actually a thing which has been like initial step for natural language processing. We daily use and actually we already been get to know about this part of speech like in 6th to 7th standard. We put into a task like even a sentence we need to find the noun, verb, objects and website. Those are the part of the speech actually. Categorizing the words with syntactic categories, example the noun, adverbs, etc. Actually, what the process of the part of speech is, it's just if a task is something like predicting something, some information from a huge bundle of text. The bundle of text should be like made into each individual elements like words or each sentence. If it's a document, it is broken down into sentence from lines from words, etc. So it's like downstreaming task where when you get every verse, the last stream is to categorize those words. And that's a thing. You maybe land up with a word which also be an adverb and a verb, which also be a noun and it also be an object. There are some categories in which the part of speech will be trying to produce the output. This part of speech actually is not being used directly by any NLP people actually, because it's been replaced by many functions, by libraries and frameworks, and also part of speech is a tagger. Tagger means like you're giving a name for the thing, name for a word. It is whether it's an adverb or noun or verb. There are many tagger, and a part of speech is like it is the most important and vital tagger for tagging a word. It may be you can also tag a word by its occurrence or by its importance in a sentence. But anyhow, if you want to make a system that actually produce a good sentence, or that actually communicate with the people a good manner, the good English, the system should know the behavior of the sentence. That means the grammar of the sentence. The object should be coming in between words. What is the verb and what it does with nouns and object. How the interlinks happen. This has been programmed by the part of speech, and there are many type of tagging like automatic tagger. This has been implemented by NLTK framework, which we will be discussing during a practical session. And regular expression tagger. I think most of the people will be knowing the things about regular expression. Regular expression is something like if it is considered like hello as A, and B as the word as B, A and B comment from hello word, and this is like A plus B star. Hello word can be repeated many times. That means hello word, etc. This is one of the example, but actually this is actually example, primary example. There are a number of possibilities for regular expression. Mostly regular expressions are being used in hacking, for cracking the password, and many other things like ATM pins and etc. Next, like lookup tagger is something like you want to make count of the number of words that you're going to tag. Are you going to tag a particular word which has been predefined before? Those things are being handled by lookup tagger, and there are much more tagger like 6 to 9 tagger, and these three are the most important tagger we're going to see about. And then example of part of speech is he is playing football externally, and after tagging he is something like now actually he will be a noun particularly, and particularly a pronoun actually, but the system produces as a noun. If we make some other toolkit other than NLTK or some other thing, there's a possibility that it exactly produced as pronoun, and display is a verb, football is a relative particle or object which we call it as object, and externally is something like that describe the verb, that is adverb. And this thing, NNVB, RB, RBR, is something like it has been named by pen tree bank tags. It is like uniform tags that followed by many people in the world. And extracting information, this is one of the important topic for NLP, because currently the system what it does you just need to produce a document or PDF to a system, just extract the information necessary for answering your question, or else the information that you exactly want to get focused on. There are taking the example of Google, there are many information in a particular website, but parsing the website content, it exactly extract the particular information that satisfy the question. So information may be of many shapes and size, maybe structured, maybe unstructured, maybe in table. Table is what we call a structure, and structure is something like what we daily write in a text, that's unstructured format. Extraction information will be totally easy with unstructured data. You don't need to know about many of the NLP techniques. Just when you store the information in SQL or table, just need to put a particular query and get the output. If it is name, ID, password, etc. that will be much easier when it's a structured data. Actually, this is what the information extraction architecture, general architecture. This is not been implemented for structured data because there's no much more complexity in processing structured data. So it's mostly employed for unstructured clumsy data. First, the raw text, that means the strings or the group of strings will be given to the sentence segmentation. As I told, downstream model, when you give a multiple number of lines with multiple number of sentences, first all the sentences are being taken and grouped along, and in the sentence all the words, that mean tokens, are being separated, and then each the tokens are being tagged with the part of speech. And then what we going to make it remove the adverbs, etc., and the information we which has been related to which noun has been related to which object. That's what we exactly need to find in the direction. In the relational object, example, you have been named with the entity direction, this noun has been implying to this object, or this object has been made by this noun, etc., and you've been put into a question with the name of the noun, and what you need to do is relate the noun with the object. That's it. The information extraction model has been over. This is conventional information extraction architecture, but this has not been exactly implemented by this by current system, because there are some changes, some distributed changes which has many companies begin to change their own information extraction architecture, but this is somewhat standard which satisfy all the principles. Next, chunking, as we do with what we call part of speech. This is chunking is also downstreaming model. In that part of speech, we just separated the entity and tagged it, but here we just grouping it. What are chunks? We call it as chunk. And this chunk, actually there are much more relation between a chunk and what you called noise, actually, because during chunking the shallow passing of the entities will be removed. It is a segmentation example. It is totally based on tokens and labels which been produced in the words and sentence. Actually, there's a thing called entity relationship. In a sentence, if you break the sentences into multiple tokens and multiple entities, there will be a buried relationship between all the entities, or maybe some other entities. This chunking reveals the buried information. If you case we saw the yellow dog, okay, the yellow dog as a whole has been produced as something related to object or something NLP, but we actually it's a noun. The yellow dog, right? The yellow dog can also be produced as a noun for another sentence. So these things actually it varies for a group of sentences where you want to particularly focus on exact tokens. Actually, mostly chunks are used for multiple tokens, and in the multiple tokens, multiple segmentation occur. Chunking is word level tokenization, but this is chunking means word level tokenization. There are much more categories in chunking which also focus on segment level tokenization. Those are tedious topics, and this is what the basics of chunking is. And it uses the same tag pattern of the POS, but what the difference is, POS exactly capture the speech part, what are the syntactic relationship of the thing with the grammar, and sequence of the POS delimited using angular brackets. Actually, this DT, JJ, NN, all POS. At a whole, it is like a chunk. Okay, can you get me? Similar to regular patterns. Regular patterns is something like this. This is a regular pattern, A star. This is a regular pattern, right? So this has been that POS has been related by the regular pattern which we call chunk. Chunking can also be done using regular expressions as v, this star, plus, these are the main contributors for the regular expressions. Then like chinking, as you and people will be knowing, like, okay, we saw chunking and the next topic is chinking. So like opposite of chunking should be a chinking. Yeah, exactly. The things that are not being included in chunk, that is like the waste part of the sentence, that can't be chunked. Exclude from chunks. Yeah, the match and remove. Actually, what exactly does is what exactly the chinking does it. They match the chink whether it is been related by some other entities. If it is not, it just removes. From the before example, the chunk is actually the saw. It has not been chunked up before, so it is like a chink. Next, the feature structure. Feature structure is like feature is something that actually plays an important role in neural network, machine learning, deep neural network. What is a feature actually? If you go for part of speech, it also there is some feature, but the feature is somewhat grammatical based feature. But what we're going to see now is a dictionary based feature. Like taking like you just make it as list A to Z and then number from 1A, 1, B2, etc. to Z. And if it like you just see a sentence ABC is a word. If you just see a sentence with ABC, what you have to do is like 1, 2, 3. Substitute those things, you will be getting a number. This number is being fed to the model or natural language processing system, because I just want to make sure that no system process languages. The languages are being converted to binary or ASCII codes and then processed. So actually if you go for deep neural network, it is being converted into matrices, numbers. So the feature structure produces a number or dictionary values that is being used for computation. This is more powerful and a responsive one comparing to the POI system. Extracting letter from the word. Yeah. We can also like get a set of words and then number it, and in a sentence substitute the number to the word. We can extract, and if we get a word from that, we can extract a particular letter. So this system produced with the downstream model. Example: dog chased him. Like consider the dog chased him, and it will be like it deals with dog chased him. Like the verb agent tool of the subject doesn't mean like take like animal list and then make a dictionary and map with a number, and like like pronoun list and action list. You'll be getting something like 1, 8, 9, where 1 is from the animal list and 8 is from the verb list and 9 is from the something like pronoun list. You'll get a pattern like something like this should be combined with this thing. That means dog should be chased. The verb agent role to the subject. That means like 1 with 5 is 8. Okay, what is the action related between the word and the for the verb and the subject? And like patient role to the object. That means like dog roles to the patient. Sorry, the guy or someone. This is being monitored when you study multiple languages with multiple features. N-grams is like if you go anywhere in NLP, I'm sure like you'll be getting a word something like n-gram, and this means hot topic till now in NLP. N-gram is like n items of context. This is some boring definitions. Generalized unigram. Actually, n-grams may be bigram, trigram, etc. But if a guy says like what is the n-gram of the thing, it just means like it's a unigram. Just make n as one. Like probability of predicting next word in a sequence with the help of n-gram model, not n-gram. If you make a model with the use of n-gram, you can predict the next word of the sentence using the current word set of occurring within a particular window. if you make a kernel window like 2 cross 2, whether like if you cross the sentence hello, then it is like hello HG as one, L as another, and O as another gram. Example, take like I like black currant ice cream very much. If the n value is 2, that means a bigram, then the n-gram would be like I like this is 1 gram, and black currant ice is another, and cream is another, and much is another. These grams have been separated to process individual elements, and like we can also fix like this starts and this ends, that makes a sentence. Okay, next, like n-gram is good, but what if it like produces nonsense words? Like if you make a system go through with a number of n-grams, and it just deduce what comes after what, and what actually what words starts a sentence, and what words ends a sentence. You're not accurate that it actually produces a meaningful word. It just produces some nonsense also. Actually, it doesn't like work with grammar, just work with the repetition of the words in a sentence. So it's like a constant structure which can be altered, and observation of units formation. Like it just makes observation how the unit sequence formed by before and after gram. Units is nothing but the word with other words, like example, like I like is an wait a minute. I like is an unit, and black currant ice is a unit. Context grammar, like this CFG plays an important role in artificial intelligence. If you go through the book of modern approach in artificial intelligence, like Peter Norvig, I think you'll make to know about propositional logic, predictive logic, context free grammars, etc. The CFG, something like it is a rule. It is something like this occurs if this occurs. Okay, it is like a formal grammar instruction for forming the production rule, how the grammar should be formed. Of like there's two things, terminals and non-terminals. There are multiple things actually, terminals, non-terminals, linkers, etc. But the two main things is terminals and non-terminals. Capital A is a non-terminal, and small a is a terminal. Like A, that's somewhat a tedious thing, which I'll be covering in mostly in next sessions, because context free grammar, there's a separate individual book for a context free grammars topic. What you need to know currently in this thing is context free grammar are used to make a form proportional logic. That means a valid logic is a production rule. That means it is used to produce words. Okay, then like context free language that we used to describe context free grammars. This is like logical understanding. I think this topic, logical understanding, has to cover much more in natural language understanding, because there is no possibility you can say that there is an ideal reasoning system in the world. There is nothing called ideal reasoning system. There may be people are working to make an ideal reasoning system. The main form of reasoning is logic. So the natural language processing engine actually gets the meaning of the sentence, not compute it, just make it meaningful. What we actually doing in natural language process is that we're just computing some meaning, just computing some mathematical formulas in a sentence, not like exactly extracting the meaning. Okay, like take a sentence with S relation to a situation in real world. The system should know that S is a sentence and the real world is something related to environment. But what we actually doing, like take the feature, take the input, process it, some mathematical equation, mathematical formula, give the output, you say it as an intelligent system. Actually, this is the thing happening today. And actually the fundamental notation is semantic. The structure is totally important for logical understanding in current scenario, but there may be some possibility that within one area or queer unstructured data can also be made as an logical understanding statement with the help of deep neural network. There are many more achievements in deep neural network currently happening. We'll be discussing it in the last session, last thing. This notion of truth. Actually, assertive sentences will be easily predicted using logical understanding. This makes this as a powerful tool for reasoning. Actually, most of the reasoning systems or expert system uses this logical understanding principle to incorporate their system accuracy, reduced to symbolic manipulation. Actually, logical understanding is nothing but a mathematical manipulation of particular symbols, where the symbols is being mapped with a particular variable, particular sentence, or particular verse or tokens, etc. Model is something logical understanding model, that means a formal representation of situation. Actually, model is a keyword for anything known as system. If you go for a tagging model, a system that tags. A logical understanding model, the system that makes logical understanding. That's what we call as a model. Formal representation of the situation. Yeah, like actually, this is something I think many people have been working on. What exactly the system does. The system should know that. Okay, the system should not able get the input and process and give the output. It should know the situation, why it gives the input and why it gives that output. This is something related to cognitive side, which that's above its and the proportional logics. This is one of the main logics. After then, predictive logic. Predictive logic is something it is something that works with structured and non-structured, that means regular and non-regular data. But proportional logic mostly works with unrelated and non-regular data. Take it as there is two sentences with A and B, and there is common group of words like this is a philosopher is a common group of words in both the sentences. Take it as P as a is a philosopher, and P is being mapped to philosopher who Socrates, and Socrates indeed mapped to take it as some Plato. I don't know what's the exact place Socrates born. And if you get if you reamp the section, you will get a relationship between philosopher Socrates and Plato. That means philosopher Socrates is a philosopher and is born in Plato. This is a logic that the system produces. These are both the links that it actually examined. In predictive logic is totally different. I will make an example for that after, because proportional logic is a bit easy to explain in a informal and basic platform, but predictive logics need to have some basic knowledge in CFG etc. Okay, it's also used in it can be replaced by Boolean operators where it's it is true or false. It actually doesn't makes true or false only. It just makes reasoning why it is true and why it is false. Proportional symbols like P, Q, R, etc. are being used. All are capital letters or non-terminals, which can be iterated after and after. Well-formed formulas actually. This thing actually, what I said actually can be written as a formula. Just Google it, and there are a number of ways to make it as a formula. Next, first order logic. First order logic is something related to the same semantic which we seen in the before thing, but actually it actually make good advantage in a sentence that actually focuses on a particular meaning. If it unbounds to many meaning, then the first order logic makes taken to be a false. Boolean operators for proportional logic actually, proportional logic we seen, right? It actually makes reasoning for Boolean operators. So first order logic actually make by using the proportional logic, it just converted as a Boolean operator. If you ask like whether Socrates is a philosopher, proportional logic actually answered Socrates has been linked with philosopher, so he is a philosopher. But Boolean operators answer like whether proportional logic works with Socrates and philosopher. Yeah, it works, so it's true. The meaning of the individual words, like example, Socrates, philosopher, can be also derived from first order logic. This logic also works with formulas and entities as we done with proportional logics. Yeah, information plus proportional logic is what you get first order logic. This is some examples of operators that is using both proportional and first order logic. Equal to, equality, not equal to, existing, essential quantifiers. That means there exists a relationship between Socrates and philosophy. All that means universal quantifier. That means sacrifice. If you put all, then like there exists a relationship between everything. That is it. It works with every sentences. Free is something. If you make off is or as a free word, it actually don't actually is and off are like chunks which have to be removed. D simplifies beta reduction on E actually. You just get chunk, and then after processing the chunk, you separate some other like less important words from the no important words. There are many more reduction in logics. And semantics, you already know, like semantics is something like particular structure. That means like this has to be formed with this structure. Principle of compositionality, like this sentence has to composite this much words and in this much way. Syntactic analysis, there's difference between semantic and the syntax. It also analyzes that parts again context free grammar. We have already seen context free grammar like used for production tool. Semantics in sentence is like there's a production tool and makes a group of word, and there's a semantic rule that checks whether the group of word sets to English grammar and works with the people. Meaning representation also can be made with semantic sentence, but actually meaning representation is not promisable with this part. Abstractly represented in logical forms. In everything we are seeing, what we've been seeing in all the slides can be represented and should be represented in logical form mathematically. Example, the ball is red. Okay, this is something like ball is made as a function. So red is made as a function to the ball. You can also make it as the ball is red ball. Example. The thing is ambiguity, like it doesn't work fine for everything. Okay, it's just a topic in NLP, and you have to know this for some other thing. You might be coming into thing. If you process something, if you get into feature extraction for sentiment analysis, chunking, sentence parsing, you'll be getting like semantics. What are the semantics? At the time you need to know some basic information about semantics in a sentence. Okay, example, like take like a word like go in a structure in a sentence with a particular structure. There's a word go, and by semantics representation, go the sentence works fine. But what if we replace the go with move, depart, pass? Go actually means the same, doesn't mean the same thing as move, depart, pass. Okay, so that sentence again fails, so it must reproduce. Okay, Okay, that's the thing called ambiguity. Okay, let's switch to programmatic side on NLP. After just before that, we just see about chatbots, so that maybe I will handling the practical session at the end of the presentation at the both NLP and chatbots. Actually, I want to say chatbots relay some concepts of NLP, but chatbots at the whole is not an NLP agent. Chatbot is service. Chatbot is currently viewed as a service like Facebook Messenger, Slack, API, Google, Hello, etc. Powered by rules and sometimes artificial intelligence. Most time rules and sometimes artificial intelligence. There is down Slackbot. Chatbots. Everybody know Natasha and and example, and there are many more things. Even Google, Facebook Messenger is the primary stage. It's beginning as a Natasha because it's being governed by rules, not by artificial intelligence. But now it's being incorporated with some neural network model which produce some good results. Yeah, it actually interface with the human language so that human can make a good conversation with the system. There are two fundamentals for making developer chatbots. Actually, there is no chatbot for general. That means generally there is no chatbots for general things. There is a chatbot for either weather forecasting or social network or some other thing. Only a specific person or specific domain people make a chatbot to make other people to interface with the chatbot to get knowledge on a particular domain. It's example, a teacher, take it as a teacher, and the personality is something, the voice, take it voice of the chatbot, whether it's a man or a man, whether or his accent of English is good or it's an Asian type, something like that. Main thing in chatbots is the interactive content. You give a word, it processes and gives the output. And again, it should not sleep as the thing, normal programs. It should again ask the word for you, and it should again pass the word and give you the result. This should be iterated for n times. In the considering the conversational kernel, there are two main types. If you give I am Murugesh, and it says I am Murugesh, and if you say who am I, it will be you are a man, you are something it will just behave sarcastic, then it is not a continuous information flow, it is a discrete information. It just processes up information in a particular discrete time and then gives output. But in a real chatbot, actually, if you say I am Murugesh, it will be some chatbots will be remembering your name and your behavior in a whole conversation, and some other chatbots even stores the value on a database or a file and then retrieve it afterwards, etc. Those are continuous information flow. Okay, how chatbots works. Okay, before we build a chatbot, we need to know how it actually works. Actually, chatbots in the first works by rule. Giving a rule if you say I, you should be responding with hello I or something else. This is a rule set of rules. That's the first thing based on a set of rules. And second thing is using machine learning principle. Machine learning is too fancy topic of 2017 and 2016. Okay, let me also work on machine learning stuff after some of the sessions. But it actually learns from what you say, how you respond, and even with the time and keystrokes you produce the input. There are many more data aspects by which the chatbots can learn your aspects, characteristics and behavior. And then these are the two main principles by which the chatbots can be worked on. There are also hybrid chatbots which works both with set of rules and machine learning principles. Like take to based on rule set is minimized, like it is imitated and mimicked actually, and also like there's a template which if this comes and this goes, if this comes and this must be the output. Pretty good examples say AML, like artificial intelligence markup language. With that framework or tool, you can build your own bot with Python in a 2 to 3 years actually. The more you spend in lines of program, the more your bots will, the more your bots intelligence will be. Then like machine learning thing is like you can embed neural networks or some other classifiers regressors in your AI bot. Mostly neural network will be used in a bot kernel that actually learns, not like it doesn't depend on the number of lines of the program, but it depends on the number of data has been put into learn. Then smartness is proportional to the learning conversation. How to build a chatbot based on rules actually, AML as I before told, and ML based is like from scratch you need to know much about vectors and matrices. There's a tool called NumPy by which we'll be computing many matrices, tensors, vectors, etc. It should be used for neural networks. And also like there are many more APIs like Facebook, Discord. Bit.ai is somewhat a famous thing for building a chatbot. And then so we finished up with natural language processing and the chatbots, conceptual and theoretical presentation. We had to finish the practical one. Now we go on for machine learning revolution. One thing I want to say is that machine learning is not artificial intelligence. Machine learning is something subfield on artificial intelligence. People usually say machine learning done this, machine learning beat the Go champion, machine learning done that. Actually, yeah, it does actually. It actually there's a set of computation symbols and computation equation. It gives the input, processes, gives the output. It just tune itself to produce that output. Okay, so this is model based intelligence, model based learning. This is not a cognitive or real time artificial intelligence. But deep learning is somewhat related to AI, but not totally actually. Both I think deep learning and machine learning is model based, and there is something like model free reinforcement and the cognitive system, which is a real, which has been invoking the real AI part of the system. There are some pretty good tutorial and mathematical equation and some randomness theory for describing the cognitive part of AI. Okay, first is like machine learning is not artificial intelligence, and then currently we are in the industrial revolution where automation is the key for industrial revolution. Yeah, automation gains its importance with the help of machine learning. Sure, it does the thing that no one can make it as negative, but also it replaces conventional practice. Most of the 90% of cars manufactured in US adapt to automation, which adapt to machine learning thing. Everything is black box system. Yeah, there's a book called WMD, Weapon of Mass Destruction. Please read the book. Actually, it's totally. She, the author, I don't know exactly what her name is, but she gives you a real time example of what the machine learning model does. Okay. And it also answers the question of whether it makes people to lose their jobs, whether it creates poverty, etc., etc. But for this session, you can't able to figure out that machine learning model works. Even the people who make the model don't know how it actually gets the feature. You give the input, it just make it feature by itself. You just produce the output. Okay, if you go take an example like AlphaGo, even the engineer in the AlphaGo can't able to predict can't able to formulate what exactly the AlphaGo does after three or fourth round, because it learns from the data. It finds some patterns that nobody can find, and then it compute that. Okay, yeah, learning from data to predict the future. Yeah, that's what the normal regression is. Actually, nowadays, money, gold is not actually the wealth. The wealth is the data. Data is the real wealth of 21st century formal going on. Because if you have Facebook account, Gmail account, Twitter and Instagram and WhatsApp, then your total data cost, what you are producing each day, is like $2 to $2.5 per day. You're producing that much data, which has been enjoyed by Google, Gmail, etc. I will also attach a link with that, by which you can able to find the recordings of your voice which you speak to Google Now. When you use Google Now API to to recognize your voice and process that thing, it stores your voice in a database. Why it actually stores your voice is that it can also recognize you with your voice. If Google makes a recognition system and then place in the mid of a town, it can able to accurately predict who exactly walks in that direction with your voice. If you're talking to someone else, it can predict like this is your voice, this boy voice, and he is talking to this boy something. Why it actually doing that? It is something like actually that's the thing, like learning their own systems of AI to make it much more intelligent as humans and surpassing humans, for getting more amount of money, for getting more amount of people, for making connectivity world, etc. They'll be blabbering, etc. For arguing their act of getting data. Okay, do you know you already signed you already ticked the I agreed the terms and conditions in the Google checkbox, providing Google access to your old data, your mail or your personal conversation, your WhatsApp, everything is open, and it's like whatever the thing you enjoy freely in your day-to-day life is open, and there's been monitored by some of the AI system which learns daily, and those things may also be fed into a Terminator, that if I say like Terminator won't kill that person, it automatically map you, then and that what's your habit, go done it. And the machine learning is success of machine learning is what the success of Donald Trump is. Donald Trump created people mentality, like he focused on the people who are actually posting wrong about him, and then he created the people mentality using media and Facebook social network, the particular people who are out against him. He get the data using the conversation, using the post, the thing. Okay, there are many much kind of stuff which you need to if you go on hear some TED talks and go for open source, the people will be discussing. Okay, and TensorFlow, many people will be talking about TensorFlow. TensorFlow is something good actually. It is actually making people to adapt to deep learning and machine learning thing without having a basics of vectors, matrices, etc. Tensors thing. These are the foundation of machine learning, deep learning thing. Without knowing them, you can just call the TensorFlow function. You made an artificial intelligence. That congrats, but you don't know how it works. This is the success of Google. You know why actually TensorFlow has been implemented? Because to get the data streams from your systems, from your models, so that the main part of the Google AI will be learning from your model which has been trained by you. I recently saw a guy actually worked with he works with NLP and uses TensorFlow. While discussing, I just said him like I can't able to implement able to implement Jacobian matrices in Theano. but I can able to make it in NumPy. He's just saying what is Jacobian matrix. Jacobian matrix is something like if you take a vectors matrices book, you'll be getting Jacobian matrix in the fourth or sixth pages in the book. That much important that the Jacobian matrix is for the matrices chapter. But current people know they don't know what the concept is, but they're actually using the tool. Please, if you plan to get into deep learning or machine learning stuff, please go with basic thing like doing the array computation yourself, doing the matrix multiplication, tensors multiplications yourself. That makes you to learn to know what exact process happening with machine learning. Okay, so that like okay, we already like diverted from the topic. Yeah, learn from the data we produce. Order of this day, yeah, machine learning is the order of this day, but not the tomorrow. Maybe tomorrow is being dependent on deep learning. Yeah, people just say deep learning stuffs like that. Not like if like deep learning is tomorrow, then what is the day of tomorrow? Something like real AI is something which will be implemented after 5 to 10 years. Yeah, sure, but not AI. AGI is AI. If you see Terminator, Robotics, Flames, etc. The program that runs the thing is not AI, it's AGI, Artificial General Intelligence, not Artificial Intelligence. Artificial Intelligence is something like if you get a system to work instinctively or reasonably in a particular field, it is an artificial intelligence. When it works in generally all fields like as we do, it's like AGI. Then like yeah, machine learning is something like it's a golden hand for like startup to get lift on. Like if you're planning, if you just figure out what is the problem in society, you just collect the data related that, just make some investment and funds with pouring on some GPUs and processor. Go to the test website documentation, read the thing, make a system, deploy it, fund it. That's it. You made a startup of machine learning thing. Models or the lifesavers for the startups. Every currently they don't go for SQL database hacking security stuff. They go for machine learning stuff because that's like promising field in getting money. Tomorrow business is guarantee. Yeah, machine learning makes tomorrow, but not the next month. Yeah, this is a breakthrough. Yeah, recent what I'm going to talk. This has been posted by 3 days before. Yeah, it's like June 15. This is the exact scenario happening in Google, Facebook, etc. AlphaGo, AlphaGo is a system, deep learning system that beat the world Go champion with the ratio of 4:1. Actually, the principle is, AlphaGo is just an initiative by Google, but currently just concentrating on cognitive systems, which actually makes not only for particular divergent like Go, but the system can learn multiple games at with a particular set of data and can reproduce it at a specific time, which they called as differential neural machines, which relates multiple models in the same model. That's something like tedious to understand, but if we go into ARXIV, there's a lot of open source papers published by Google, Facebook, and deep neural network, and also like Google trained their system to play Atari games, etc. That plays as much good as human, but the thing is, you just need to make 2 lakhs playing iteration to make the system play as good as human. But we do, with like 10 or 20 steps, we do make a good move. There's some drawbacks. But like Facebook image tagging is something like a breakthrough by Facebook. What do you think they can do? Give an image, it can predict what the thing in the image, give you the output. This is what you've been thinking. But recently, Facebook made a CI. If you give it like a word, like bird, with with red color wings and yellow color peaks, sitting in a palm tree, sings a song in a sunny day. If you say this thing, the Facebook image tagging system, that means the Facebook image system, automatically creates the image itself. A cuckoo bird, sitting in a palm tree in a sun day, it automatically create. Can you believe it? But this is what actually happening by the Facebook image tagging. Thanks to you and me, myself, and all other guys, we are totally responsible for Facebook image instincts, because like what we give them as image, what we post our image, Facebook learns from it. Just try in a low internet connection, just try to load Facebook. It won't be loading the image. Instead of that, it will be loading the caption. If you just make a selfie, it will be like a boy with a selfie background something. It just learn from your images, and now it can predict. It can create its own images. That type of network is called CANs. Next thing is personal assistants like Facebook, Siri, etc. There is like somewhat slightly slow improvement in personal assistant stuff. Search engine Google, yeah, everybody know Google, Yahoo, etc. Slack is also producing some good search engine nowadays. Yeah, okay. We are like describe something about AI systems and machine learning, revolution, machine learning thing, etc. But there's a question in a group that actually whether AI steals our jobs. Actually, yeah, they do steal our job, but that doesn't make ourselves as jobless. If you're doing a job, okay, it just replace you in a job, and makes you to make yourself free, so that you'll be learning a new thing and you'll be focusing on new ideas to make something new thing. And also there are some particular areas like services, arts, entertainment, all other things that AI can't able to make ourselves. AI can't able to make service as good as humans. AI can't able to make music or like dance stuff like that. Still now AI progress only in softwares, not in the motors or sensors, and not in the other thing. There may be a progress, but not as slow as software AI thing. But even though the ultimate AI bonds, it is like a great question mark whether it replaces humans with serving nature, like helping people's blood donation, etc. Yeah, robot don't have blood, but helping people is a thing that humans only have. And living in a world that with lot of changes and evolutions, robot can also evolve in a normal state, but it makes humans to make to have free time to think some other thing than our normal work, which is being replaced by machines. We are already living a machine type of works and lives that need to be replaced by a machine, and we can live our own lives with new other thoughts, etc. There are both negative and positive impact on AI. As Stephen Hawking told, if original AI has been born, it must be a greatest good in the human history or greatest bad in the human history. It's up to us and what we get, what data, what model we make. That's make the thing. And that's it. Thanks for the presentation. And we'll be seeing the practical sessions soon.